Okay, week 28, part 2. So in this lesson we're learning about double angle formulas or identities and half angle formulas or identities. And we're going to be using these for similar things where we're basically finding the sine of some angle where that angle is not, that's a theta right there, is not 30, 45, 60 degrees, etc. It's something different. So that's what we're using these for. And your notes look like this. So the double angle formulas are right here. We got sine, cosine, and tangent. Notice how there's lots of space here for cosine because there's 3 variations. So definitely write those all in. Alright, here they are. So you can pause and write those all in. Ooh. Yeah, okay. And then for the half angle identities, see how these are, the angle u is being divided by 2, and we could call this x or y or theta, whatever we want. But the formulas are written in terms of that, so I thought I'd use that variable. So here we have the formula for sine, and there's going to be a plus or minus in each of these, and so the plus or minus depends on whether that angle would actually have a positive or negative value for sine. So for example, this angle would have a positive value for sine, but a negative value for cosine. So you're going to have to kind of draw out a little circle, triangle, and think about it. So there's our formula for sine. Here's our formula for cosine. So you can write that in, and then for, whoa, hey there. And then for tangent, we have 2. So, and there's extra space, so there's our formula, there's one formula for tangent, and here is another variation for tangent. So you can pause that video and write those in wherever you need to. Notice how there's extra space for both of those variations of tangent. Okay, next page, couple examples. So, one example says, find the exact value of sine of 22.5 degrees. So we definitely don't know that. We could use a calculator, but the whole point is to be able to do this without the calculator, using our brains for worthwhile stuff. And so 22.5 degrees, we recognize that that's half of 45. So we can say sine of 22.5 degrees is the sine of 45 divided by 2 degrees. Notice how I highlighted the 45, okay? Using half angle identity, let's see, sine of u over 2. So we have plus or minus. Now, why does this look wrong? Oh, that looks right. I was looking at the wrong formula. Okay, plus or minus, and 1 minus cosine of 45 degrees over 2. And so we still have this plus or minus, all right? When you think about 22.5 degree angle, it's about right here, okay? So the value for sine is y, is obviously going to be positive. So you see how I did away with the positive and negative because we know it's going to have a positive value. Alright, so 1 minus cosine of 45 degrees. We know that the cosine of 45 degrees is root 2 over 2 using our unit circle skills. So there, that's our number. The rest is just sort of algebra simplification type stuff. And if you're not really down with your square roots or your common denominators, this is going to be tricky, but you'll see that this is popping up all over the place, so you definitely have to know how to do this. So when we have a complex fraction, or compound fraction, sorry, meaning there's a fraction within a fraction, okay, you're getting a common denominator up top and down below, right? So I have a common denominator up here. I've written 2 as 2 over 1 so that I can, dividing by a fraction is the same as multiplying by the reciprocal. So this is where the 4 comes from in the denominator and 2 minus root 2 in the numerator. Going from here to here, we basically turn 1 into 2 over 2 so that we'd have 2 minus root 2 all over 2. Okay, so common denominator, and then dividing by a fraction, same as multiplying by a reciprocal. And then from here to here, we basically just recognize that the square root of 4 is 2. So that can come out of the square root sign, and it's down below. So we have a 1/2 times 2 minus root 2, square rooted. Plugging this into Desmos gives us 0.382 blah 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 blah. Taking the sine of 22.5 gives us the exact same thing. So you don't have to do this, okay? And we're looking to get this answer without using Desmos, but I know that when you get an answer like this, you're like, well, is it right? Who knows, right? You look at that and you have no idea what it is in terms of a decimal value, so the calculator can tell you that you are correct. Okay, another example that is similar, but we're using radians, and we did this example in previous notes using, I think it was pi over 4 minus pi over 6, so the subtraction formula or identity, but we can use the half angle identity as well. So pi over 12 is pi over 6 divided by 2, so half of pi over 6. So we can say cosine of pi over 12 equals cosine of pi over 6 divided by 2. And again, this is helpful to us because we know what the cosine of pi over 6 is. Pi over 6 being 30 degrees. Okay, so we have plus or minus 1 plus cosine of pi over 6 all over 2. And we're thinking about positives or negatives. Cosine of pi over 12, right? It's our original question. Pi over 12 would be this little skinny angle right here, and we know that the cosine would have a positive value. So we can just know that it's going to be a positive. Okay? So what happened? How did we get that? Ah, right. 1 plus cosine of pi over 6. So that's where the root 3 over 2 comes from. Your unit circle skills. And then 2 and 2. So this, you could type this into the calculator and you'd get the same number that we're going to get over there. But again, we're doing common denominator. So the 1 turns into a 2 over 2. So we get this 2 plus square root 3, and it's over 2. And the 2 down below we think of as 2 over 1. And we can, dividing by a fraction is the same as multiplying by the reciprocal. So this turns into that, which is where we get the 4 and the 2 plus root 3 up top. So again, square root of 4, the 2 comes out, and it'd be 1 over 2 right here, yielding this, and I checked in Desmos, and Desmos tells us that this is that, and it tells us that this is that. So we can pat ourselves on the back. Good work. Alright, and then lastly, so this way of thinking is definitely important, where we create this triangle. So let me talk this through. The question, and you have some of these in homework to practice, it says, find the tangent of u over 2. So that looks just like one of the half angle identity formulas that we have on our notes on the other page. Find tangent of u over 2 if sine of u equals 2/5 and u is in quadrant 2. So u is the angle. We know the sine of the angle is 2/5, and we know the angle is in quadrant 2. So this information is actually important. If we were to draw this, all right, all we know is that the sine of u, the sine of some angle is 2/5. And we know that the sine, whoa, hey, that's not a 2, that's a 5. We know that the sine is the y-coordinate, so 2/5, I just approximated, it's about right there. Alright, so we split this into fifths, and 2/5, okay, so the sine is right there. There are two angles, so there's this angle, theta, and there's this angle, which we're talking about angle u. Both of those have a sine that is equal to 2/5. So the fact that they told us that it's in quadrant 2, right, this is quadrant 1, this is quadrant 2, means we know we're talking about that angle. And that's important. So from there, I did this, and I drew a right triangle. And because the sine So sine is opposite over hypotenuse. Because the sine is 2/5, I knew that the opposite side, I could say that the opposite side is 2 and the hypotenuse is 5. Even though we know that for a unit circle the radius is 1, but so this is kind of like a trick. But we said the sine is 2/5. We use Pythagorean theorem to find this. So the a squared plus b squared equals c squared, meaning 2 squared plus, and let's call that x squared, equals 5 squared. So that's how I figured out that the length of this side would be square root 21. Now, because we're thinking about this in terms of the unit circle, we know that for sine this is positive, cosine this is positive, cosine this is negative. That's where this comes from, because this is useful to us when we're sort of coming up with the cosine of that angle. So what I can say is that we have that angle u up there, and we could say that the cosine of that is this over this, the adjacent over hypotenuse. And this negative comes into play because we know that, so it was that's angle u. This angle is going to have a cosine that has a negative value. So, so this is, we're going to see this a lot. Alright. Based on this information, we could say that the tangent of that angle is opposite over adjacent. We could say that the cosine of that angle is adjacent over hypotenuse. Let me zoom in here. And we could say that the sine, well, we knew this already, is 2/5. Okay, so we can use this information and plug into the half angle identity that we have. So, the half angle identity that we have is that the tangent of u over 2, which is what the question is asking for, is 1 minus cosine u over sine u. So from that information down there, we know that the cosine is negative root 21/5, and we know that the sine is 2/5. So boom, that's our answer, that's a number. The rest is just simplifying. So this turns into this. How do we do that? Common denominator of 5, so this, the 1 turns into 5/5, which is where we get 5 plus square root 21/5, and then down here we have this 2/5, and so again, this dividing by a fraction, same as multiplying by the reciprocal, and the 5's cancel, giving us, oh, I wrote that out here, giving us this. And let's see. Well, yeah, that's good. Alright, so I know that's tricky, but this process over here we will see more of, where we're sort of creating this triangle based on what we know the sine or cosine or tangent to be. And we'll get some more practice. The ones we'll be doing most frequently are these kind, where you're asked to find the sine, cosine, or tangent of some angle that is not 30, 45, 60, 90, etc. Okay, thanks.